Hi, and welcome to this short video explaining how to work out predictive values for diagnostic tests using event trees. And so let's start by exploring what is in fact an event tree. Alright, so an event tree is simply something that looks similar to this, and in this case it's filled out for a diagnostic test. So we have an animal gets sampled, and that animal can either be disease positive or it can be disease negative. Now, if you had a perfect test, then everything that was positive would test positive and everything that was negative would test negative. But the truth is most tests we work with are imperfect. So for both disease positive and disease negative animals, we can either have a test positive or a test negative. And so the net result, and why we sort of call it a tree, is that we have 4 branches, so A, B, C and D. Okay, now we can determine the probability that a randomly selected animal will be A, B, C or D, and we'll work through what those probabilities are. And let's start by thinking about the probability A. And so we would say the probability that the first part of that branch occurs, so that the animal is disease positive, is going to be our prevalence. Okay, and that is, going to come from the literature or from your knowledge of the farm, if it's looking at a smaller unit. And we need to combine that with something which we talk about in the probability theory context as the probability that we test positive conditional on being disease positive. And this vertical line that you see here means conditional. Or another way of saying it is, what's the probability that we test positive given we have disease? And that is really just asking us about the test sensitivity. Okay, so the probability that we test positive given we have disease is simply the sensitivity. So because we want to know the probability that firstly we have disease, and then the probability that we are going to test positive given we have disease, we're simply going to multiply these two probabilities together to determine what's the probability of A. And so that's prevalence multiplied by sensitivity. So let's move down and have a look at the next branch of this option here, which is to test negative. So again, we need to know what's the prevalence in order to work out the probability of B. But we also need to know how likely is an animal that has disease to test negative. So that's going to simply be 1 minus the sensitivity, because you can be either test positive or test negative if you have disease. Okay? So the probability of B is prevalence multiplied by 1 minus the sensitivity. Alright, so let's move on to look at D and C, where we are now focused in on the disease negative branch. And so we can be 1 minus the prevalence, because you're either disease positive or you're disease negative. And then the probability of D is going to be the probability you test negative conditional on you having disease, which is a fancy way of asking for the specificity of the test. So again, the probability of disease is 1 minus the prevalence multiplied by the specificity. And so if we now look at the final branch for us to calculate, we know that to get to here is going to be 1 minus the prevalence, and then from here to here is going to be 1 minus the specificity, because if you don't have disease, you either test negative, which is the specificity, or you test positive, which is 1 minus the specificity. So that's going to give you 1 minus prevalence times 1 minus specificity. So if we now put them all here, you can see that for each branch of this event tree, I have a way of determining how likely A, B, C or D is to occur. And so I can use that information to work out how likely is a randomly selected animal to test positive. Now there are 2 branches in this tree that will give me a test positive, and that is the diseased animal testing positive or a disease negative animal testing positive. So because it could be this or this, I'm going to say that the probability of testing positive is the probability of A plus the probability of C. So that's prevalence multiplied by sensitivity plus 1 minus the prevalence multiplied by 1 minus the specificity. So that should be starting to look familiar in terms of predictive values, but we've still got one more thing to add. And so the next step would be to say, okay, what proportion of these are going to be test positive? Which we can write in probability theory as going to be the probability of A divided by the probability of being test positive, which we know is this. So what I'd like you to do now is pause this video and substitute in the values for the probability of A and the probability of test positive to see what you get. Okay, welcome back. So when you substituted in sensitivity and specificity and prevalence, you should have ended up with the positive predictive value formula that you've seen elsewhere, which is the sensitivity multiplied by the prevalence, that's the probability of A, divided by the probability of A plus the probability of C. Okay? Alright, so to test your understanding, we're now going to move on to look at negative predictive values, and starting at the very beginning, I now would like you to think about, to work out what is the probability a randomly selected animal will test negative. So pause the video, scroll it down, and then when you're ready, start again. Okay, and welcome back. So remembering where we left off, we wanted to know the probability a randomly selected animal will test negative. So there's only two ways that can happen, and that is it doesn't have disease and it tests negative, or it has disease and it tests negative. So we're wanting to add this to this, which should look like what you see below. Alright, so now, again, pause the video and determine the probability that a randomly selected animal that tests negative is free of disease. Okay, so welcome back, and so you should start with our test negatives. And just as for the positive predictive value, we put the true positives over all the test positives. Here we're going to put the true negatives over the test negatives. So we're going to put the probability of D and we're going to divide it by the probability you test negative, which gives you the negative predictive value that you saw previously. Okay, so this is showing you essentially from first principles where these formula come from. Okay, and I personally like this approach because it doesn't matter what I'm being asked for, negative or positive predictive values, or what's the probability an animal that tests positive doesn't have disease. I can work any of them out when I conceptualize the problem in this way. Now, everyone's mileage varies and the way people think about problems varies. So if this has kind of muddied the water for you, it's not resonating with you, don't agonize about it. Kind of put it to one side, go back and have a look at the 2x2 table approach, or have a look at the British Medical Journal reference that has been posted to the forums, and just kind of take some time to think about it, because these are not straightforward concepts when we start adding formula to them. Alright, well, happy hunting, and we will talk about this some more in the forums.